In this video, we'll be looking at domain and range for relations and functions. First, a few definitions. In a relation, the domain is the set of all the values of the independent variable x, and the range is the set of all the values of the dependent variable y. We're asked to give the domain and range of each relation, and then tell whether the relation defines a function. So in our first example, we have a set, and it consists of 4 ordered pairs. So we know this is a relation. Our domain will be the set of all x's. So -4, -1, 1, and 3. Don't forget to separate your elements of your set with commas. Our range is the set of all y values. So -2, 0, 2, and 5. Then we're asked to tell whether the relation defines a function, and yes, it does. And to check to see if it does, you just need to check that every x is paired up with exactly one y. So -4 goes with -2, -1 maps onto 0, 1 maps onto 2, and 3 maps onto 5. A good way to check for this is to make sure that your x values are not repeated. Try another one. This time our relation is shown with a mapping. Our domain is all of the elements that are in this oval. So our domain is the set 1, 2, and 3. Our range is the set of elements in this oval. So our range is 4, 5, 6, 7. Now the only thing that would make this not a relation would be if any elements that are in either the domain or the range are not mapped onto another element. But we can see that everything's mapped onto a number. So to determine if this is a function or not, I have to check that every element in the domain is mapped onto exactly one element in the range. So the 1 is mapped onto 4. The 2, however, is mapped onto 5 and also onto 6. So because of this, this is not a function. In this example, our relation is given in a table, and we can see that our x values, which is our domain, consists of the set -3, 0, 3, and 5. Our range, which is the y values, is just the number 5. Now we don't repeat elements in a set, so we'll just list that 5 one time in our range. Now to determine if this is a function, -3, is it mapped onto just 5? Yes. 0 mapped onto just the number 5? Yes. And only one number each time. So 3 maps onto 5, just the 5, and 5 maps onto 5. So this is a function. In our last example, we have the equation y equals 3x plus 1. This is a linear equation. The graph is shown here. Now our arrows on the ends of this line represent that this not only goes forever down and up, but also forever left and right. So our domain is all real numbers. The way we'll show that with interval notation is from negative infinity to positive infinity. And the interval notation we need is open parentheses around the interval. We use open parentheses to indicate that this is not a specific number, because once you think you're at negative infinity, you can always go a little further. So the open parentheses and the closed parentheses indicates an open interval. And likewise for the range, this also is all real numbers, so an open interval from negative infinity to positive infinity. And this is a function. All lines are functions except the vertical line, so this one is a function.